In this lesson, we're going to take a look at probability distributions. We're going to take a look at a given frequency distribution, and we're going to construct the distribution. Then we're going to calculate and interpret the mean, the variance, and the standard deviation. These are going to be manual calculations, as it's generally difficult to find technology to calculate the mean, variance, and standard deviation of a probability distribution. The calculations can be somewhat tedious, however, it's not so difficult if you create a chart with which to keep track of your calculations. I'm going to show you how to do that. So if you follow along, you'll see that it's not all that difficult. A company tracks the number of sales new employees make each day during their 100-day probationary period, and the results are given in the chart that you see here. The sales per day are given as 0, 1, 2, 3, 4, 5, 6, and 7. And the number of days are 16, 19, 15, 21, 9, 10, 8, and 2. So what do those numbers mean? The numbers that you see in column X list the possible number of sales in a day. So in a day they could have had 0 sales, 1 sale, or they could have 4 sales, or 5, or 6, or 7 sales in a day. So the frequencies in the other column tell us how many days those sales occurred. So for the employees, 16 times there were 0 sales, 21 times there were 3 sales, 10 times there were 5 sales. All right, so that's what each of those numbers represent. So let's take a look at how to find the mean, variance, standard deviation, and let's talk about how to interpret that data. Does us no good to do these calculations if we have no idea what that information is telling us. So to construct the probability distribution, which essentially a probability distribution is just a big fancy name for a chart that sets up the event with its probability listed beside of it. So a probability distribution is just a chart, and we want to write the event with its probability correlated to it. So in order to do that, the first thing you need to do is find the sum of the frequencies. And the sum just means to add. So to find the sum of the frequencies, we add up the number of days in our F column here. We add all that up, and it equals 100, which it should equal 100 because we were told in our problem it was the probationary period of the first 100 days. So that's our first step in constructing a probability distribution. The second step is to calculate that probability. In order to find that probability, we divide each frequency by the sum, and that tells us the probability of that particular event. So, as an example, let's find the probability for the frequency of 16. So 16 out of 100 is 0.16. We do the same thing for 19. Probability of 19 out of 100 is 0.19. The probability of 15 is 15 out of 100. And they're all done the same way. You continue on until you've filled in the entire column, dividing each one by 100 and determining its probability out of 100. So we have a probability for 9 as 0.09, for 10 as 0.10, for 8 as 0.08, and for 2 as 0.02. So now we're ready to construct and find the mean of this probability distribution. One final thing to check before we move on to the mean are the characteristics of a probability distribution. In a probability distribution, it's important to note that every probability value must be a value between 0 and 1. Remember, all probabilities are between 0 and 1. We can't have a probability that's less than 0, and we can't have a probability that's greater than 1. probability can't be greater than 100% or a negative value. So double check each of your values and make sure that you don't have anything greater than 1 or less than 0. If you do, you did a calculation wrong or something is faulty with your data. You should also double check the sum of all of your values and make sure they total up to 100% or 1, depending on what format you have them in. If you have them in percents, they should equal 100%. If you have them in decimal form, they should equal to 1. Calculating the mean of a probability distribution means that we take the sum of each x, multiply it times its probability. So that means we have to take each x, multiply it times the probability that you just found, and then add all those answers together. So let's take a look at how we do that. I create a new column in my chart. Remember I said it's very important to keep this organized in order to make this process as simple as possible. So 0 times 0.16 is just 0. 1 times 0.19 equals 0.19. 2 times 0.15 equals 0.30. And I just keep going. 0.21, oops, I put my decimal in the wrong place, times 3 equals 0.63, and I continue on to fill in that chart, and I see that I have 0.36, 0.50, 0.48, and 0.14. The final step for calculating the mean, once I have all of those values, is to add all of them up. When I add all those values, I get a mean value of 2.60. So the mean of my probability distribution is 2.60. So that's a little different than just calculating a regular mean that you're used to, which means we added everything up and divided by the number of values. We have to actually multiply times our probability and then find our sum. And we're not dividing by anything. So what does this mean tell us? This mean tells us that on average, a new employee makes 2.6 sales per day. Variance and standard deviation of a probability distribution. This formula looks pretty scary, but it's not. If you just break it up into parts and then put it all back together, it comes out quite smoothly. Again, keeping it organized in a chart is the key. So we need to use that mean that we just calculated. And here's how. The first thing we need out of our formula is this x minus the mean. So I create a column in which to calculate that portion. So for that, we're going to take our x minus our mean and record that. So 0 minus 2.6 gives me a negative 2.6. X minus the mean, so 1 minus 2.6. 1 minus 2.6 gives me a negative 1.6. 2 minus 2.6 gives me a negative 0.6. And I can continue on to fill in each of those values. 3 minus 2.6 gives me 0.4, 4 minus 2.6 gives me 1.4, then 2.4, 3.4, and 4.4. So I've filled in that part. The next part that I need to complete is to square each of those values. This is the part of the formula that I'm going to do next. So I'll create a column in which to put those results. And I'm going to just square each one of these values and enter the result right here. I'm going to take my calculator and I'm just going to square them one at a time and enter the result. So negative 2.6 squared gives me 6.76. Negative 1.6 squared gives me 2.56. Negative 0.6 squared gives me 0.36. And I continue on in that same manner. My results are 0.16, 1.96, 5.76, 11.56, and 19.36. Again, I'm just working my way through this formula until I get to the end. Now I've got each component of my formula. I can do the last bit of multiplication, which is to multiply my probability of x times this squared difference between the x and the mean. So these two highlighted in orange columns, I've highlighted them since they're so far apart. I need to multiply them together. So if I multiply 0.16 times 6.76, that's going to give me the results of my final column. So 0.16 times 6.76, I'll write that in here. I'm going to run out of room though. Gives me 1.0816. And my next product is going to be 0.4864, and that was found by multiplying 2.56 times 0.19. And then I'll multiply 0.15 times 0.36 and get 0.0540. And then I'll continue on multiplying in the orange columns to fill in the rest of this final column. Once that column is filled in, I'm at my final step, finally, which is to sum up all of those values. Notice that sideways E? That is to sum up all of these values right here. And that's going to be our variance. So if we add up all of those values that we just calculated, we'll have our variance. So adding all those up, we get a variance of 3.72. What we're really interested in, though, is our standard deviation. Our standard deviation gets us back into usable units. So standard deviation is the square root of the variance. So taking the square root of the variance gives us 1.9. So what does that tell us? What does standard deviation tell us in terms of this problem? In terms of this problem, deviation tells us that most of the data values differ from the mean by no more than 1.9 sales per day. So we found out that on average, the salespeople made about 2.6 sales per day, and they were within 1.9 sales of that. So that was pretty good. They were all clustered within 1.9 sales, and they usually made 2.6 sales per day on average. So I hope this has helped you make a probability distribution and construct and calculate the mean, variance, and standard deviation. I know it takes a little time, but if you keep the information organized in a chart, it's not so bad.